Hi everybody. Here's going to be a preview of a big idea from our lesson on Tuesday. This is another installment in the series of how to think about clean coding. So this was the problem that you guys worked on and that you turned in drafts for. Your method was supposed to output a table like this representing a number of steps that Alice will take in her random walk, and then on the other side here, the average ending distance, or the expected ending distance for how far away will she be after those end steps. Okay, so let's jump to code. In class, we'll look at some of your code that you produced. There's a number of interesting bugs, and I don't think it's an accident that those bugs happened. I think that this is a complex thing that you're trying to create, and bugs are a result of complex logic. So the way to eliminate the bugs is to make your logic simple. And controlling that complexity and making simple logic is what clean coding is all about. So I want to illustrate kind of how I would approach this, and this is a technique that I think that you totally can emulate. So public static void main. So I'm going to start by creating a method that will just do what I want it to do. So display table of expected distances up to, and then 100. So I'm not saying my name here is great. I'm making up the names on the fly. This feels a little long to me, but the idea is I'm going to make a method that does the thing that I want to do. The method is going to display this table. Okay, so let's create it. One thing I will point out about my naming, up to 100. So my parameter here kind of fits into my name, so it reads like English. Except I is not a very good name for it. Let's call it like max num steps, because that's what it represents. So display table of expected distances up to some maximum number of steps. Okay, so I'm not even going to worry about how do I calculate the things, how do I blah, blah, blah. The job of this method is just to display a table. So let's do this. Int step num starts at 1. Step num goes up to max num steps, and then step num plus plus. Okay, so what am I going to do if I'm displaying a table? Let's look at the table again. So number of steps and expected end distance is what it says. So let's do s out for standard systems.out.println, and I'll say num steps, and then some tabs, and then expected end distance. And then what I want to do inside my table, let's think. So I guess I already have the number of steps, so now all I need to calculate is expected end distance. So let's let's get expected end distance for however many steps we're on, step num. I'm going to rename this. I don't like step num. I like number of steps. That seems clear to me. Okay, how is this going to work? I don't know right now, and I don't care, because that's not the part of the problem I'm thinking about. This is one of the ways you're going to control the complexity, is you think about different parts of the problem separately from each other. That's the whole idea of creating methods, is that you can create sub-problems that you can postpone thinking about until later. So let's just assume that this works and that it's going to give me the expected ending distance. So now all I have to do is display them. So let's do system.out.println, number of steps, and then let's do a tab, and then let's do expected end distance. Okay, so this is going to display my table perfectly well, assuming that this method works. Let's create this method. For testing purposes, let's just return 0.0 right now, and we can just run and see if the table looks the way that it's supposed to. And cool. So num steps, expected end distance, it's giving me something that makes sense. I mean, maybe I want to fiddle around with the tabs and so forth, but that seems okay. All right, so let's do 2 tabs here and like 1 tab here. Now let's run it again. Okay, that's probably fine. Okay, one more set of tabs. Okay, so now let's think about get expected end distance. So now I'm thinking, oh yeah, I forgot all about how to do this. So always think about what is it you're trying to calculate, and then what's the overall algorithm. So in the slides that I showed you originally, these same slides, we've got this pattern. If I want to calculate some average distance, I'm going to run a whole bunch of tests, a whole bunch of trials. So in each trial, Alice will take her n random steps, and then I'll figure out how far away did she end up, and I'll add that into my sum, and then I divide by how many trials I had. That's, in general, how you find an average. So let's just do that much. So get expected end distance for. So I guess I'll have a double for average distance. Well, we'll do that at the end. So I'll have distance sum starts at 0, and now let's have a loop for trial number, and the trial numbers are going to go up from 0 to max trials. And I'm going to make this a constant. I could pass this in as an input, but I don't know. I'm feeling it as a constant right now. So let's have 1,000 trials. That might not be enough, but we'll see. So I'm going to run 1,000 tests, and inside each test, what I'm going to do is I'm going to do random walk for a certain number of steps. This is not a great name because it doesn't tell me what it's returning. So let's say get end distance for random walk and the number of steps. All right, how does this work? I'm not thinking about it right now because that's a sub-problem. So let's just assume this is going to have Alice walk randomly and then return her ending distance. So that's into distance. So now I just say distance sum. Why is this not working? Distance sum plus equals distance. So now I'm adding the distances into my distance sum, and then at the end I'll return distance sum divided by max trials, because that's how many things I did. So now this pattern literally just calculates the average for this thing. So see how I'm solving my problem one step at a time, starting from the simplest, highest level thing. How do I display a table? And I'm not worried about where do I get the number in the table, because that's a sub-problem. I'm just thinking, how do you display the table? Okay, so now that it displays the table, I'm thinking, all right, how do I get that number that I need? Okay, well, the number is going to be an average for a bunch of trials. So let's just make a pattern for calculating an average. And how does the actual trial work? How do I actually take the steps? I'm not thinking about that yet. So now we make sure that works. All right, so now let's do this step where we're doing a trial. Okay, so I'm going to actually take a bunch of random steps in my random walk. So it seems like so this is my current step num, and we're going to go from 0 up to number of steps. I guess I need to keep track of where Alice is, so I'll create an X and a Y for where she is right now. She starts off at the origin. I'll need to choose her direction randomly. So int direction equals math.random times 4. So that's going to be an integer between 0 and 3. And so I'll say if direction equals 0, x plus plus. Are these magic numbers? Yeah, a little bit. If direction equals 1, then x minus minus. If direction equals 2, then I'll change the y. If direction equals 3, then I'll subtract from the y. Okay, so one of those 4 things is going to happen. Let's see here. What did I want to do now? So let's think. I'm starting at the origin. I'm taking the right number of steps. In here, we're actually having her take a step. Do I need to do anything else in there? I don't think so. So let's just return distance to origin from xy, because that's where she is right now. And then that will be her ending distance. Okay, that makes sense. If I'm thinking about defensively coding, I haven't done... There's a couple of possible places for bugs. Like, what happens if I had the wrong number here? In that case, maybe maybe I wouldn't have equal probability of doing these 4 things. Like if I did 3 here, now I'm never going to run this line. If I had 5 here, maybe sometimes direction would equal 4, in which case she wouldn't do anything. She would just stand there, and then the probabilities would be wrong. So my coding is not terribly defensive here. But this is feeling simple enough to me that I feel like I don't need to. Let's go ahead and write a distance method real quick. So I'm going to return math.square-root of, let's see, x times x plus y times y. Does that make sense? Yeah, that makes sense. Okay. And I think those are all the pieces I need. So let's go ahead and run it. Okay, this seems like the right kind of output. Let's see if it changes if I go up to 10,000 trials instead of 1,000 trials. And the answer is a little bit, but not a whole lot. Okay, so the reason I wanted to show you this is because I wanted to illustrate how I chose to decompose this problem. And in class, and you might be thinking, well, that seems fine, but like it seems like a lot of methods. It feels very kind of broken into pieces, and in a certain sense, if you did this all in one chunk, that might feel more unified and more logical. Like that makes more sense. And I'm going to show you in class why I think that approach is more likely to lead to bugs. Okay, thank you very much. See you in class.